as you probably know very well, there's a lot of work trying to introduce LLMs to recommender systems. And one particularly interesting use case of LLMs is to use them to derive this natural language or a text profile representing the user's preferences. So this is the overview of the method. We collect some metadata of items the user has interacted with. We give this metadata to an LLM via prompt, asking the LLM to generate this natural language summary of the user's preferences. So we're using LLM as a summarization device. And then we can do recommendation. So there are multiple ways to do recommendation. For instance, we could ask another LLM to rank some items based on the user's profile, or we can also embed both the natural language profile and item metadata into the latent space and do recommendation in a more traditional way. So there are many advantages of this approach, especially coming from the fact that the profiles are understandable. So users could read their own profiles and see what the recommendation system understands about them, which increases transparency and also builds trust. It's also great for cold start scenarios where a new user could just come and write down their preferences and already be getting recommendation. And it's also very good for user control because if we allow users to edit their own profiles, they could scrape some things they don't want to listen to anymore and add new preferences. Therefore, they could be controlling their recommendation, something that would be very costly to do when you are deriving user preference models from interaction data. Okay, this is all very nice, but before we move along, we take a step back and we ask ourselves 3 questions. First is, do users actually recognize themselves in these automatic generated profiles? And then, is self-recognition aligned with recommendation performance? And last, is the quality of the profile biased towards some kind of user or some kind of item? So to answer these questions, we did a user study. We collected streaming data of 64 users. We generated our profiles and we gathered some feedback. For every user, we had to sample some items to represent them. To do that, what we did was for a given time window, we would rank the artists they have listened to the most. So in the paper, we used 15. And then for the top 15 artists, we get the most listened to track. And then we collect the metadata of these tracks and we use them in a prompt to generate the profiles. So we're using this time window to sample the tracks. And if you have a short time window, then we get items that represent whatever the user has been listening to lately, which can be quite exploratory and very noisy. And if we increase the size of the time window, then we have a better long-term representation of the user's preferences. They're more well-established, but perhaps outdated. So in the paper, we use 4 different time windows, short ones like 30 days and bigger ones like 360 days. And from the sampled items of these time windows for every user, we prompt 3 different LLMs to generate their profiles. We used 2 open source ones, so DeepSeek and Llama, and Gemini 2.0. So every user had 12 profiles. To these 12 profiles, we added 5 fake profiles that came from other users. And the user study was quite simple. We asked users to read the profiles and rate from 1 to 7 how well the profiles describe their own taste, from 1 not at all to 7 very much. So for the results, we see that users, they did rate their own profiles higher in comparison to the fake ones, the baseline, showing that they do indeed recognize their own taste in the profiles. Then we had a look at the increase of the rating that a user had in comparison to their baseline, which is what we see on the y-axis here. And what we noticed is that the time window that we chose to sample the items had no significant effect on the ratings, showing that as long as users saw part of their own taste reflected in the profiles, they would raise them higher. The biggest effect came from LLM choice. So every LLM had a slightly different way to frame the profiles. For instance, Llama focused more on names of artists and tracks, which seems to please some users, while Gemini had more high-level descriptions of taste. All right, then we checked to see if the self-recognition was aligned with recommendation performance. So we fine-tuned this bi-encoder model that we have used in the past. So we're embedding both the profiles and item metadata into a shared latent space. And then we try to predict items that the users had interacted with, but they were not used in the generation of the profiles. So what we found out is that there was a weak alignment between RecSys and NDCG with self-identification. So even when users recognize themselves the most, doesn't necessarily mean they're getting the best recommendation, or at least doesn't mean that we can predict the items they interacted with the best. Okay, so then we look at some user characterizations and how they relate with the ratings. So we saw that specialist users, given by the GS score, they tend to have higher ratings. Because when you're a specialist, your taste profile is a bit more narrow. Therefore, it's easier to represent this with just some like 15 items and also a short text. We also see that older users and users that listen to older songs also have better ratings. So younger users, they tend to listen to new songs that are not yet present in the training data of LLMs. Therefore, LLMs have a harder time generalizing their own preferences. We also had a look at some item characteristics and how they correlate with the ratings. So we look at the genre and the country of origin of the tracks. And we see that, for instance, metal, rock, US, UK, and Canada music tend to correlate positively with the ratings, while French music, world music, and rap tends to correlate negatively. So we know that LLMs are trained on internet data, and there's a lot of high quality data on American music, especially metal and rock. Therefore, it's easier for LLMs to generalize this kind of preferences, while, for instance, French rap is not very well represented, which seems to result in poor profiles. Of course, we don't only look at correlation. In the paper, we control for some covariates using a W-reboost method, and we show that indeed the presence of some tracks do affect the ratings positively or negatively, especially metal and rap music. So the main takeaway is that, well, when we use this approach, users, they do recognize themselves in the profiles. However, the style of the profiles matters. We show that recognition is not completely aligned with recommendation performance. And also we show that there are some biases that appear. So depending on the items used to represent a user, they're gonna have a better or worse representation, which leads to fairness issues when you're using LLMs to represent users. Thank you.
Do user profile descriptions and item descriptions embeddings match, or are they close enough in the latent space?
So we find, I guess this relates to the recommendation setting we did, and we fine-tune a model to project both the user profiles and the items used to generate them close together in the space. And that's how we did recommendation. We tried to predict the other items by embedding similarity.
Thank you very much for the presentation. Super, super interesting. When you did the user study and there was kind of some agreement and maybe some less agreement, and so on, did you notice a little bit more how this was correlated to the recommendation itself? So you said that the user profile, people could recognize them to some extent. I will assume it's not perfect. But if you measure this, how they feel they were represented or how maybe they will have like to change it and how this correlates to how you do the prediction.
Right. So like if you allow users to correct their profiles, if you would result in better predictions.
Or if you see the disparity in how the user recognized the profile. So it was positive, but I'm pretty sure it was not perfect. It was not 100%. There was some variety.
Yeah, there was some variation, especially in terms of, for instance, age or GS score. So some users had better profiles than others. And but what we see is that even when we do recommendation following this setting, even the users that recognize themselves the most, they don't get the better recommendation.
Okay, interesting, because there's always this question about should we trust the user to actually tell us what they want?
I think it's also come from the fact that the question we ask is like how well we represent your taste. We didn't ask if you match the recommendation you want to get, because you don't want exactly to listen to what you already know. Recommendation about discovering new things. So sometimes you might listen to things that you don't know yet. So there's a mismatch there.